4. This is the fourth method that we want to use to solve quadratic equations. Number 1 is factoring. Number 2 is graphing. Number 3 is square roots. Remember, square roots, there's no x. And then the fourth one is complete the square. All right, so complete the square. There's some core concepts. It's tiny, tiny little writing, but we wanted to get it on the page. But that's just a bunch of humbly jumbly of reading stuff. But basically, complete the square is the fourth one. We're going to learn another one tomorrow or whenever we do 9.5. It's called the quadratic formula. You might have seen it before. You might, not have seen it before, but get a drink there. Complete the square to me is the easiest of the hard ones. So factoring is the fastest, but you need to know how to factor. Graphing is the safest, but sometimes graphing doesn't work out best. You'll find that out in Algebra 2. Square roots is only specifically for no x terms. So then we needed another method in case we couldn't graph it. Complete the square and the quadratic formula can work for all problems. I personally think complete the square is a little bit easier, but we're going to show you both and require you to do both on your quiz and your test anyways. So how does complete the square work? Okay, well, when we do factoring, we have this thing called a perfect square trinomial. So we have an x squared, and then we have a number in front of x. And then if we have the perfect number in this spot, if that no x term is this term, the number here, and we cut it in half and then square it, then it will factor down to what's called a perfect square binomial. Okay? So let's see it with some numbers in play. All right? So number 1, identify the value of c that makes it a perfect trinomial, then factor to write the perfect square trinomial. So all I have to do is take this number, cut it in half, that's 4, and then square it. So 4 squared is 16. So in this problem, c needs to be 16. Okay? Then we factor it. So I'll write it out. This is x squared plus 8x plus 16, and it will factor. It's just a neat little trick. This is modeling. You need to pay attention and understand how this works, but this will factor into a parentheses of x plus, and then whatever this number is, squared. And that's the trick to completing the square, is you take this number, cut it in half, square it. That's the c value that goes in the blank, and then you factor it. It always factors into a parenthesis, and then x plus or minus that number squared. So watch. Half of 6 is 3. 3 squared is 9. So I need to put a 9 right there. That's my c value. C is 9. And then I factor it. So I draw a parenthesis, and I do x minus, and then half of 6 is 3, and the square root of 9 is 3 squared. So that is x minus 3 squared. Half of 10 is 5. 5 squared is 25. So c is 25. And then we factor it. That's x minus 5 squared. And then it doesn't always work out perfect, but that still means we can do it. Half of 5 is 2.5. And then 2.5 squared. So sometimes we need our calculator. 2.5 squared is 6.25. So my C value is 6.25. And then it factors to x plus 2.5 squared. So that's called completing the square. Is you add a number that's perfect. Only one number will work. Okay? All right. So complete the square method allows us to solve quadratics that aren't factorable. So none of these, I mean, some of them can factor, but we're not going to use the factoring method. We're going to use the complete the square method. So the trick to complete the square method is you have to get all the x's on one side and the non-x's on the other. So look at these first 1, 2, 3, 4, and 5 are already set up for us for complete the square. Okay? So all we do is take the left side and find that perfect number. Half of 8 is 4. 4 squared is 16. So we're going to write x squared minus 8x, and then we're going to add 16 equals negative 15. Then we're going to add 16 to this side, because now we're solving an equation. Whatever you do to one side, you do to the other side. You're used to subtracting and building equations down or tearing them down, but you can also learn how to build equations up. That's advanced math. So instead of tearing this equation down, we're actually going to build it up. Okay? So 16 is the perfect number because it's half of 8 is 4 and 4 squared is 16. But whatever I do the one side, I do the other side. Okay? The reason I put a 16 there is so that I could factor it to x minus 4 squared. And then the right side, I combine my like terms and I get 1. All right? Once I have the perfect square done, now I solve using square roots, because I got rid of the x. It's a neat little trick, okay? So then we square root both sides. That leaves me with x minus 4, and the square root of 1 is 1. Don't forget your plus or minus, okay? Add 4 to both sides, so I'm going to get 4 plus or minus 1. So then I add. 4 plus 1 is 5, so I get an x equals 5. 4 minus 1 is 3, and I get an x equals 3. Remember, we get 2 answers sometimes. Sometimes we get 1, sometimes we get none, but this time we got 2. Okay? All right, here we go again. It's set up for complete the square. I got the x's on one side and the non-x's on the other. So what I need to do is find that perfect number. Half of 12 is 6. 6 squared is 36. So watch. You're going to add 36 to the left side and then add 36 to the right side. The left side factors. So I have x minus 6 squared, and that is 46. We're going to roll with it. Okay? Square root both sides. And that leaves me with x minus 6 is equal to plus or minus root 46. Now, the directions in your notes say round your solutions to the nearest hundredths, but I wasn't paying attention to the directions. This is how I would want to teach it. I want you to leave your square roots. So we're going to leave non-perfect roots as square roots. Okay? Basically, don't break it down because it's not a perfect square. So I'm going to add 6 to both sides. So then my answer is kind of goofy, but it's going to be 6 plus or minus root 46, and we're done. So it's going to be, when it's a perfect square, you're going to get your numbers, but when it's not a perfect square, you're just going to leave it like that. Okay? All right. So that opens up some possibilities for us. Okay, number 4. Half of 15 is 7.5, and 7.5 squared is 56.25. So we're going to take x squared minus 15x, and then we're going to add 56.25 is equal to 18. Then we're going to add 56.25. I kind of ran out of room. My fault. Factor the left side. That's x minus 7.5 squared. And then the right side, that adds to 74.25. Our numbers aren't perfect with the complete the square method, but it's manageable. Pretty sure that's not a perfect square. I better double check. So the square root of 74.25. Nope. So we're going to leave it. So we square root both sides, and we get x minus 7.5 is equal to plus or minus root 74.25. Then we add 7.5 to both sides, and we get our goofy looking answer, but it's right. It's 7.5 plus or minus the square root of 74.25. We do it like this because sometimes on the SAT, we have no calculators, and we need to practice writing our square roots without a calculator. Hopefully we get some better numbers soon, but we'll see. All right, number 5. Half of 7 is 3.5. I don't know what 3.5 squared is, but I can type it in my calculator. 3.5 squared is 12.25. So we're going to write x squared plus 7x plus 12.25 is equal to 30 plus 12.25. Okay? Factor the left side. We get x plus 3.5 squared. And then the right side, we get 42.25. Pretty sure that's not a perfect square, but I'll double check. The square root of 42.25. Ooh, 6.5. So yeah, we can use that one. So square root both sides, and we get x plus 3.5 is equal to plus or minus 6.5. So that's kind of cool. Now we're going to minus 3.5 to both sides and make our calculations. So negative 3.5 plus or minus 6.5. Remember, that just means you're taking negative 3.5 and you're adding it to 6.5, and then you're subtracting it to 6.5. So when I add it, I get 3. And then when I subtract it, I get negative 9.5. So a lot of work with complete the square, but it's really cool. Okay. All right. Number 6. So this isn't set up, but all I need to do is just take the 9 and send it over to the other side. So watch. X squared, and then I have minus 26x. Half of 26 is 13. 13 squared is 169. But then I remember I got a minus 9, and then to balance, I had to add 169 to that side. And the reason we did that is so that we could factor the left. X minus 13 squared is equal to 160. Well, 160 is not a perfect square, so we're going to square root. We get x minus 13 is equal to plus or minus root 160. Then we're just going to leave it like that. We're going to add 13 to both sides. Not the best numbers, but we get the idea. Okay. All right, number 7, here's a neat little trick. I want to show you, we do this in Algebra 2 sometimes, but to complete the square, if there's a number here in front of the x squared is really hard. But what's cool about quadratics is if I take this, because it equals 0, and if I divide it by 2, dividing 2 by 0 is still 0. So I can take and divide this whole thing by 2, so cut all the numbers in half, and I'll get the same answer. So I get x squared minus 6x minus 5 is equal to 0. So I think that's kind of cool. All right. This can't be factored, so I'm going to solve it using complete the square. So watch. You take x squared minus 6x. Half of 6 is 3, and then 3 squared is 9. So I'm going to add 9. Okay. And then I have to add the 5 to the other side, and then also add 9 to balance. Another non-perfect square, whatever. So factor the left, that's x minus 3 squared. It's equal to 14. Square root both sides, and I get x minus 3 is equal to plus or minus the square root of 14. Pretty sure the square root of 14 is not perfect, so we're just going to add 3 and get our goofy looking answer. 3 plus or minus root 14. All right, we're just going to do a whole bunch until we can get the hang of it. 2 more. Okay. So 3 goes into both of those. I don't like having the big number in front, so 3. So I'm going to just divide everything by 3. X squared plus 2x minus 8 is equal to 0. And now I could factor this. I'll show you real quick. I'm going to factor it off to the side. That's x plus 4 times x minus 2. So I'm predicting that our solutions are negative 4 and 2. But the directions say we need to solve using the complete the square method. So in order to get our points, we need to show the method. So we're going to add 8 to the other side, and then take half of 2 is 1, 1 squared is 1. So we're going to add 1 to both sides. So x squared plus 2x plus 1. Add 8 to both sides, and then I have to add 1 to balance. It's got to be detailed and pay attention to your numbers. Factor the left, that's x plus 1 squared. 8 plus 1 is 9. Square root, so I'm going to square root both sides. That leaves me with x plus 1 on the left, and on the right side I have plus or minus 3. Then I minus 1 to both sides, so I take negative 1 and I have to add it to 3 and subtract it to 3. When I add it to 3, I get 2. And when I subtract it to 3, I get negative 4. So factoring is a lot faster, but not everything is factorable. Like this one over here might not be factorable. Okay? All right, number 9. I don't want that number in front, so I'm going to divide everything by negative 2. So be careful. That's x squared. And then negative 16 divided by negative 2 is a positive 8x minus 7 is equal to 0. And that doesn't factor. Okay? So we're going to use the complete the square method. Half of 8 is 4. 4 squared is 16. So I'm going to add 16 to both sides. And don't forget to add the 7 to both sides. Factor the left side, that's x plus 4 squared is equal to 23. Square root both sides, and you get x plus 4 is equal to plus or minus root 23. 23 is not a perfect square, so we're going to minus 4 to both sides to get our solution. So it's negative 4 plus or minus root 23. Awesome, you guys. Very, very, very cool. All right, challenge and extend, not on the test. Without graphing, determine whether the quadratic function has a maximum or minimum value, then find the value. So it's almost a review of what we did in chapter 8. Okay, so I guess it's a good review. I left mine here thinking it'd be kind of cool. Now I'm kind of regretting it, but that's all right. I think we can do this. We can crank this out. So this is a good review of chapter 8. Well, because the number in front means my parabola is going to open up like this. So number 10 is going to have a min. Okay, well, I guess it's good to review. It's in standard form, so I have to do A, B, C. And then remember our formula to find the vertex is negative B over 2A. So what's negative B over 2A? That's negative 6 over 2 times 1. Negative 6 divided by negative 2 is negative 3. So that's my x coordinate of my vertex, negative 3. Now take negative 3 and plug it in, and that'll tell you your minimum value that we're looking for. So I have to take negative 3 and put it in parentheses. When you square a negative, it always goes in parentheses. I'll show you, right? Because negative 3 times itself, what's negative 3 times negative 3? It's 9. What's negative 3 squared? Negative 9. What's parenthesis negative 3 parenthesis squared? If I square the parenthesis, 9. Pay attention to your calculations. You have to think of these scenarios. A negative times itself is a positive, okay? Plus 6 times negative 3 plus 10. So what is that calculation? That's 9 minus 18 plus 10. I think it's 1. So we know it's a minimum, and we know that minimum value is located at 1. Okay, let's do another one. Because my parabola is negative, that means it's going to open down, and that means this is a maximum. All right, here's my A, B, and C. So I can see now why we did this, because we're going to learn the quadratic formula soon, and you need to know your A, B, and C. So let's do negative B over 2 times A. So I have negative 8 over negative 8, that's 1. So my x coordinate of my vertex is located at 1. Now I take 1 and plug it in. So what's negative 4 times 1 squared plus 8 times 1 plus 12. So that's negative 4 plus 20, so that's 16. So there's my maximum value. We could find that on a calculator by graphing, which we're going to do next, actually. And then number 12, I told you a lot of the story problems we're going to let you use your calculator. So this is a review of graphing 9.2. So we're going to solve these problems using our graphing calculator. So a diver jumps off a diving board. Here's the function, represents the height and feet of the diver after X seconds. What is the maximum height of the diver? How many seconds? Blah, blah, blah. Let's get the graph first, okay? So it's negative 16x squared plus 6x plus 5. And then my window looks like my window goes from 0 to 1 and 0 to 10. So watch. X min 0, X max 1, Y min 0, Y max 10. So there's a picture of the dive. I want to go up just a little bit. And let's get some key points, okay? Well, I know the diver jumps from a height of 5. So I'm going to plot 5. Let's find the height of the dive. That's called the maximum. So second calc max. Set my left boundary, and my cursor is way over here. I know my maximum's up here somewhere. and then set my right boundary. I have to go all the way to the right of it to make sure I got it. Okay, I went down a little bit. And so it's at 0.187. So 0.1, 0.2. So it's right close to 0.2, and it's at 5.5625. So there is my maximum. And I'm going to write that down as a coordinate. So 0.187, comma, and then my maximum is 5.5625. Okay? And then I got to find the zero. But when does my diver make it to the water? That's the 0 button. Second calc, 0. So I've got to go all the way over and set my left boundary. So my cursor is now to the left. And then I'm going to set my boundary. I think it looks like I got to go underneath it a little bit, to the right of it. There I go. I'm underneath it. Can't see it anymore. Enter. And then enter. So it looks like it goes in the water, 0.777. Okay. So that's at 0.777, comma 0. So there's my parabola. There's the diver. Cool? All right, so there's our graph. Now let's answer the questions. What is the maximum height above the water? That's that number. So height, max, 5.5625, and my units are in feet. Okay. About how many seconds does it take for the diver to reach the maximum height? 0.187 seconds. And then they could ask, when does the diver hit the ground? That would be 0.777 seconds, but they didn't. So complete the square method. Nice job, guys.